Okay, next video. Here we are on example for a dumb pilot, and all that means is that, say, a plane wants to head exactly east to get to their destination, but they don't account for the fact that the wind is blowing from the northeast, and so the plane ends up not going where they want it to because they think they can just head east, when in fact the wind will push them a different direction. So, a couple things to note about these types of problems are, well, for starters, when we refer to direction of wind, you got to be careful. And what I mean is, this says the wind is blowing from, so I'm going to underline that, from the northeast at 30. If I go over here and I draw what's happening with our vectors, and we'll say black is the airplane, we'll call that P. So P for plane, P. So just the plane, not worried about wind, not worried about anything else. It has a due east, so that is directly east vector. That is P, and it is 600 to the right, so 600 positive, 0 in the y direction. It's not heading north or south in any capacity. Then we have our wind. The wind, going back to what I was saying, it is from the northeast. You know what? Yeah, no, it's just going to call it northeast, so we're going to assume that's exactly 45. So the problem is that that's not saying that it's going up and to the right to the northeast. That's where a lot of people get confused or mess things up. If it's from the northeast, we actually have to redraw that vector, because this is saying it's headed to the northeast. So we want to draw exactly the opposite, where it is from the northeast and headed to the southwest. We'll call that vector W for wind. And vector W, well, let's see, that's, oh, we got to figure out what are the XY coordinates. Well, we know the magnitude's 30. We need to know what angle. And since we're using, we are going to use the, the azimuth directions. So we need to figure out this angle right here. So here's 180 to get straight south, and then we have to add another 45 degrees to get to the southwest direction. So 180 plus 45, that's 225 degrees. Okay, so that's the first thing to be careful of. Remember, we're talking directions in terms of our bearings, so we need to be careful and refer to due north as 0. Once we get that right, we say that the XY coordinates of any vector, given the magnitude and the direction angle, so 225 degrees, we know that the x component is the magnitude cosine of the angle, so 225, comma magnitude times sine of the angle. Okay. So we have P and we have W. The resulting vector is just going to be just like we've been doing, vector A plus vector B. Our resulting vector of the airplane is, sorry, I'm going to draw this in black, P plus W. So we just say 600 plus whatever this number is, and 0 plus whatever that number comes out to be. Okay. I could note that that's negative 21.213. And this is also negative 21.213. And if we take a second to look at this, negative values, right? Well, if we're looking at the XY coordinate system, we're pointed down and left. So that's why our X component is negative, pointed down, so our Y component is negative. So now, I actually screwed that up because I already used the black marker. I'll use green, right? Because I've said in the past I always use green for my resultant. So let's stick with that. So P plus W. So 600 plus our negative 21, that is 578.787. And 0 plus the negative 21, that just gives us our negative 21.213. So if you think about it, our was thinking maybe I want to redraw W. Okay, W is not very big compared to our P. We want to show that respectively. So P is 600, W is only 30, so I did want to shorten that up quick. The other thing I'm going to do is try and draw, again, if you did head to tail and you looked at these resulting vector, that's kind of going to be more just, oops, sorry, I thought I was in green. Change that quick. Right, so our resulting vector is going to be 578 in the x, but just 21 and negative 21 in the y. Let's see, did we answer the question? Plane traveling, the wind is blowing that. What is the plane's resulting heading and airspeed? Okay, well, believe it or not, we haven't answered either of these questions. Question 1 is the heading, and we'll get to that here in a moment. But the airspeed is going to be the, see, the ground speed is 600, right? So that's for another day. I'll take another minute and describe that. But that would be like on the ground. That's how fast you're traveling. The airspeed is going to be if we account for the fact that the wind is also pushing us in a certain direction. So the fact that the wind is kind of in our headwind a little bit, even though we think we're going 600, the airspeed, we're actually only going to be going less than that because some of that wind is going to slow us down. So what we want to know is what is the magnitude of P plus W? Right, that will actually be our airspeed. That's how long is the resulting vector. Then the bearing or the direction, the heading itself will actually be that angle from north. So the absolute value of P plus W, so I'm going to shorten it, just 578. Please do not shorten it to that when you run it in your calculator, but just for screen space, I am shortening it quite a bit. But the magnitude is 579 miles per hour. Okay, so that is actually our airspeed. The airspeed is like what is the speedometer actually showing that you're traveling with respect to the air. If we wanted to know what angle this is, see, so we're going to be from north at 0, and we got to travel around to this fourth quadrant. Let's see, let's draw that triangle. So we've got 578, and we go down 21. Here's our angle theta. So tangent of theta is opposite over adjacent. If we do tangent inverse or arctan in our calculator, so second tangent, and then you put in that fraction, you find that that is 2 degrees. Problem with 2 degrees is that 2 degrees is just from the x-axis because we're using cosine.
For the following students.
Sorry. So, whereas before we could just end and say, okay, yep, we've got 2 degrees from the x-axis. We need to say, well, we're actually going from north to east, so 90 degrees plus the additional 2. So our heading is 92 degrees. Okay. So that is the heading, that is the direction. I will end this video and a separate one for the Smart Pilot.